Welcome back. This is part 2. Last time we went through the task, identified the variables, wrote a method, and explained the accuracy improving techniques. Now we're moving on to the good stuff, right? Making our raw data table. If this video isn't helpful enough for you, I've also given links to another teacher from another school explaining the steps. So why not watch both? So, raw data table. I'm going to open up Excel. I recommend you just pause the video now, open up Excel, and get to this stage right here, where you have your links and you have your 3 trials. So yeah, pause the video, get to there so you can follow along. All right, welcome back. So raw data table, excellent. We have our length. Remember, we chose at least 5 independent variable values. So 0.2 meters, length in meters, 0.2, 0.4, 0.6, 0.8, and 1. Now, with that measurement, our ruler went to millimeter precision. So our uncertainty would be plus or minus 0.001 meters, which is, what's that, 1/10, 100th, 1,000th of a meter, 1 millimeter. And why it's plus or minus 1 full millimeter is because you take a measurement on both sides of the ruler, and each side is plus or minus half a millimeter, so together it's 1 full millimeter. And a little trick I did there is if you double click the green dot in the right corner, it extends it to the end of your data table. Great, so we have, so far, our independent variable. We have an uncertainty, and it's rounded to one significant figure. Right, very important. I'll even just put it in the column to remind us. Absolute uncertainty is always rounded to one significant figure. And now, this is a step you might miss, but our length, right? We wrote 0.2 meters. However, our precision was actually to the millimeter. So we need to select our length, and at the top for number, we can increase the decimal places up to 3 dp because our uncertainty was to 3 dp. Right? We have millimeter precision, so our measurement needs to reflect that. And I'll just copy this down to our process data table for later. Awesome. And now for each length, we measured 10 time periods. So 10 periods in seconds. And I'll just merge and center that. It is satisfying having a nice raw data table, so take your time, color code it, do what you do. We have all 3 trials. There's one mistake. Can you spot it? It's in trial 2. This one right here. Yep. Notice all our other measurements are to 2 decimal places. So let's just be consistent, right? Because our stopwatch did go to 2 dp. But I'll show you in the process data table how we can work out the other uncertainty using the half range rule, because that might be worse than the reaction time. Cool, so our 3 trials, what do we need? Next, we need to calculate the average. So in Excel, well, you could use your calculator, add those up, divide by 3, or equals average, make sure you spell it right, open bracket, so that's Shift 9, you click and select your cells, so cell C3 up to colon E3, close bracket, enter, and that is the average. And like before, if you double click this little green dot or click and drag it down, you will get all of your averages. Now that looks quite messy, right? Look how many dp these went to. For now, let's just round it to 2 dp. Again, using the number button, but this time decreasing the decimal, like so. And so that was the average. But now, since that was for 10 periods, we need it for 1 period. Again, just having the units in the column header. To get for 1 period, it would equal the time for 10 periods divided by, so that's next to the right shift button, / divided by 10, enter. Double click this green dot, and again, select the cells to format to the correct number of decimal places. For now, we can leave it to 3. And you'll see in the process data table, we correct any rounding that we need. Excellent. That is all done. We have our raw data table. Now, before we jump on to the process data table, this is optional, but highly recommended. You plot the non-linear graph. This is to ensure that you are on the right track. Because if you're not, you need to stop and go recollect your data. Yeah, I know. So take your time on the first time and you won't need to do this step. So to make your graph, we do this. We select, click and drag your independent variable. So click. If you're not very nimble with your trackpad, you click the top cell, you hold shift and use the arrow key, like so. Holding control, you now select the time period, like that. So we've selected the length, so our x-axis, held control, selected the y-axis values. You go to insert, charts, see this one with the dots, and you select the first option, which is the scatter graph without this like moving average line. Right, so this one right here. Now, right now it's pretty basic. We need to include a title, label the axes, as well as draw the non-linear curve. So double clicking the title, we can simply call this period versus length. If we hit the little plus here, if you're on Mac, under chart design, you need to go through this menu up here. Yep. But if you're on Windows, you can hit this plus. So what do we want? We want the axis titles. We will also want a trend line, but I'll get to that in a sec. So on our x-axis was our length, measured in meters. And optionally here, you could also give the symbol, which is capital L. So length, symbol L, measured in meters. Period, symbol T, measured in seconds. So that's looking good. What have we got so far? We've got a title, labeled axes, the origin is shown, and our last step is to add the non-linear curve. So to do that, you add a trend line. If you hit this box here, it'll automatically give a linear trend line. We don't want that. So hit the arrow, more options. Now, this does get confusing in Excel, but you have 3 tabs up here. Most of the time, you're going to want to be in this one with the bar graph, which gives you like the technical options rather than the styling options. We don't want linear. We expected a square root graph. So that's not exponential, it's not logarithmic, it's not polynomial. Polynomial would be a squared graph. It's in fact a power relationship, right? To the power of a half is the same as the square root. So for square root, we select power. For squared, we would select polynomial. For inverse, it would also be power, and for inverse squared, it's also power. Yeah. Now we can display the equation. Optional, but good to do. and even the r² value. And we can close this window, click, drag. You can even increase the font size. Oh, come on. Just to make it a bit more readable. Change the color, whatever you want. Make it look nice. Great, so we have added a non-linear curve. Do not make the mistake of adding a linear trend line here, even though it may look a little bit linear. That could be because your range of values wasn't wide enough. We still need to linearize the data. So what does this tell us? This tells us time period is equal to about 2 times length to the power of 0.46. A perfect square root relationship, the power would be half. So since it's pretty close, I'm confident that we can move on and that our data is suitable. Before moving on though, we need to ensure that all this great work in our Excel file is represented in our report. So the easiest way to do that is you select your raw data table, Control C, go to your report, add a bit of space, paste, and if your data table was a bit of a behemoth like mine, see this white dot on the right, you can just drag it and shorten it to that. Alternatively, you could take a screenshot. Yeah. Likewise with the graph, click, Control C, paste it in. And center it, because we want it to look pretty. So let's just double check. We have a raw data table, yep, with our independent variable, uncertainty, 3 trials, average for 1 period. We have also plotted our non-linear graph, including title, axes, curved trend line, displayed the equation, and that r² value. If r² is equal to 1, it means the trend line perfectly follows your data point. So since it's close to 1, I'm pretty confident it is close to a square root relationship. Cool. And lastly, for this video, we need to state the relationship between the variables. So this is free because in the task we are told the relationship, and we have partly verified that with this graph. So we will just say, oh look at this, I've already done it right here. Beautiful. Paste it in. So from the non-linear graph above, the period y is proportional to the square root of length. And if you want to be fancy, because why not, we can write this expression. So to do that, Alt equals, or insert equation, capital T is proportional to, so backslash, that's above enter, prop 2, so that's the shortcut for proportional to, space, and then square root is backslash sqrt, space, capital L, space. So time period is proportional to square root of length. Here we go. We have done that one. And now again, at this stage, if you don't see a clear square root relationship, as in you aren't on track to verify the theoretical equation, you stop, you look at your method, and then you gather results. So you could just copy this whole raw data table and then just update these, and since you've already put in all the formula, it will update your averages as well, right? So just quickly get your data again and then move on from there. Alright, so quick recap. We have made a raw data table, being specific with the headings, giving the units, ensuring our uncertainty is to 1 sig fig, correctly rounding, to our uncertainty precision, calculated averages, plotted a beautiful graph, and stated the relationship. And so in the next video, we'll be moving on to our processed data table, which is probably the hardest part for most of you in that it's different from last year. So I'll see you in that one.